In this topic, you'll learn how to keep a certification authority from becoming a single point of failure. We'll identify what must be backed up, explore GUI, certutil, and system state options, and build practical recovery procedures you can execute under pressure. You've already taken PKI from concept to working infrastructure, designed the lab, built AD, deployed ADCS, and issued certificates for servers, users, and devices. Now we're shifting the focus to the CA itself, how to secure it, back it up, and recover when something breaks. Certification authority is the root of trust for your entire PKI. If you lose it without a backup, you can't sign new certificates, publish CRLs, or process renewals and revocations. The private key, the CA database, and the configuration all work together. Losing any one of them breaks trust. Solid backup and recovery planning keeps certificates flowing, shortens outages, and prevents widespread application and user impact. A CA backup is really a backup of the entire service, not just a single file. You must protect the CA certificate, and especially the private key. You also need the CA database and logs, registry and policy settings, plus all templates, permissions, locations, and runbooks that describe how it operates. Think of the CA private key as the master signing seal for your entire PKI. If it's lost, the CA can't issue new certificates or CRLs. If it's stolen, an attacker can impersonate your CA. That's why you back it up rarely, store it encrypted, and lock those backups in a tightly controlled location. The CA certificate is the public face of that seal, and you'll need it to reestablish identity and rebuild trust after recovery. The CA database is the system's memory. It records every certificate issued, every request that failed, and every request still waiting. Most importantly, it tracks which certificates were revoked so your CRLs stay accurate and clients can trust revocation checks. Database logs add another layer, capturing detailed changes so you can recover cleanly after failures. If this database is lost or corrupted, you lose reliable history, and revocation management quickly turns into risky guesswork. The registry is where your CA's operational personality lives. It controls how long certificates and CRLs are valid, where CRLs and AIA information are published, and which policy and exit modules run. If those values change during recovery, clients may stop trusting new certificates or fail to find revocation data. That's why a registry backup is just as critical as the database and CA keys when you restore a CA. Certificate templates actually live in Active Directory's configuration partition, not inside the CA. Active Directory is the source of truth for which templates exist, who can use them, and what they're for. The CA simply reads those definitions and decides which templates it's willing to issue. Because of that, documenting template names, permissions, and use cases is essential for troubleshooting enrollment, controlling certificate purposes, and planning any disaster recovery of your PKI. Backups only help if someone can actually rebuild the CA. Treat documentation as part of your recovery media. Capture the exact CA configuration, names, domains, OS version, and role services. Document every CRL, AIA, and CDP location so paths can be recreated or updated. Keep an inventory of templates, permissions, and enrollment rules. Then write step-by-step recovery procedures and store them, along with passwords and key contacts, in a secure but accessible place. The Certification Authority console gives you a guided way to capture everything the CA needs to survive a disaster. From the menu, launch the Backup Wizard and select the private key and CA certificate when they're available. Add the certificate database and its logs, so issued certificates and revocation data are preserved. Then set a strong password and store both the backup files and that password in secure, well-controlled locations. Certutil gives you a predictable, scriptable way to protect your CA. Start by creating a dedicated folder, like C:\K backup. Run certutil backup to capture the CA database and configuration. Then run certutil backup key to export the CA certificate and private key. Store that folder somewhere secured and offline when possible. Finally, verify the command succeeded and document the date, location, and credentials needed to restore. System state backup is your safety net for the entire Windows server, not just the CA. Think of CA-specific backup as protecting the brain of ADCS, while system state protects the whole body. System state captures the registry, system files, and key OS configuration, so you can rebuild the server itself after a major failure. You still need certutil or console backups for the CA database and keys. Use both together for reliable recovery. Your CA backup is like a master skeleton key. If someone gets it, they can impersonate your entire organization. Protection starts with people. Only a tiny trusted admin group should handle these backups. Then add strong encryption and unique long passwords for any exported keys. Keep at least one copy offline or in an isolated vault, so ransomware can't touch it. Finally, log every backup move, restore, and destruction step for full accountability. Recovery planning is about proving your CA can actually come back to life. Begin by practicing full restores in a lab, not during a real outage. Keep the CA server name and CA common name consistent, so existing certificates remain trusted. Confirm domain, DNS, Active Directory, CRL, and AIA paths all work after the restore. Then capture everything in a disaster recovery runbook, including validation steps and who does what, so recovery is repeatable under pressure. You're now responsible for keeping the CA alive, not just configuring it. Back up the private key, certificate, database, logs, registry, templates, and documentation using the CA console, certutil, and system state together. Protect those backups, practice restores, and carry this mindset forward into Module 5 troubleshooting.